All right. Last video, and then we'll have the recap. But we want to talk about one-sided derivatives. Obviously, derivates wasn't what I really meant to put there. That should be derivatives. One-sided derivatives come up because the question is, what happens if I'm looking at some function and then the function stops? There's obviously a slope of the line right here, a derivative there, and there's obviously a derivative there. But what happens at that point? Because I can keep getting closer and closer and closer and closer and closer. So why can't I say, well, this is what happens really close to that point? And the answer is you can say what happens really close to that point. So what we do is we say that you have a one-sided derivative on a closed interval. So let's say we're looking at a function on the interval AB, closed interval AB, and our function looks like that. And this is at A, and this is at B. And we are going to have the limit as, I'm going to go ahead and change colors here, the limit as x approaches B from below, and we're going to have the limit as x approaches A from above. And we are going to, in fact, be able to define the derivative inside this interval. So let's say we had the function. This will be example 6. We have a piecewise function, y equals x squared for x less or equal to 0, and it equals 2x for x greater than 0. And we say, okay, well, let's find the limit, the derivative as x approaches 0 from below. Well, this is the x squared equation from below. And so what we're going to have is we're going to have x squared minus 0 squared. We're using the alternate at a point definition over x minus 0. And simplifying that, we get x squared over x. We get x, and the limit as x approaches 0 from below of x is just 0. Okay, what about the limit as x approaches 0 from above? Well, we're now looking at a different function. We're now looking at 2x. So what have we got here? We've got 2x minus 2 times 0 divided by x minus 0. Well, doing some simplification, that's 2x divided by x, which is 2. So as I approach from the left, my slope equals 0. As I approach from the right, my slope equals 2, which means that there is some kind of corner here. So if I'm looking at this function, what I actually have is I have a parabola, slope equals 0, or is approaching 0, and I have a line, slope equals 2, and right here, the slope is undefined because it is different on each side of that point. This is the problem that I had on that original test. We hadn't got a chance to take a look at it. I did, by the way, take it off your scores. I just basically nulled that one out, in case you were wondering. So, why don't you guys do exercise 31? And that is the end of chapter section 3.1. I will be back with a recap video a little bit later. But in the meantime, you should be able to be working on all of the 3.1 homework, which is listed in the assignment in Google Classroom. And we'll see you next time.